All right, good morning class. Once again we got another lab to do. This is lab 6-2, Zener diode current characteristics. The objective is to demonstrate the characteristics of a Zener diode. And a review of those characteristics of a Zener diode. Remember, when it is connected in forward bias, it will act as a standard diode. In other words, it will conduct at its standard diode forward bias barrier potential of around 0.7 volts. When we connect it up in reverse bias, and that would be the cathode to the positive and the anode to the negative, it will then, provided that the source voltage is greater than its Zener rating, it will conduct and regulate at that Zener voltage in reverse bias. Okay, so the purpose of this lab is to become familiar with the current characteristics of a Zener diode, both when the diode is forward biased and when it's reverse biased. When the Zener diode is forward biased, it acts basically as the same as a normal diode. When it's reverse biased, it acts as the same way as a normal diode, except that when its breakdown voltage is exceeded, it is not damaged. Instead, the voltage across the Zener diode after breakdown occurs is relatively stable. This characteristic makes the diode particularly useful for voltage regulation and protection of other devices against overvoltage. So, if I pan down a little bit here, you'll see that I've got my Zener board connected up. I'm just going to zoom in a little bit too, if I can. I guess I gotta shift you over. Whoops, sorry, going backwards here. That's better. Let's try to get everything on screen here. So I've got my power supply, I've got my meters here. So the purpose of this meter here is to measure the source voltage. This is my ammeter to measure the circuit current. And over here, this meter here, I should probably zero that if I can. I can't. The purpose of that meter there is to meter the voltage across that actual Zener there. So I've connected it up in the lab as they first state. They wanted it connected up with the anode to the positive and the cathode to the negative through this 500 ohm resistor, which is on here. Okay, so in doing so, we've connected it up in forward bias. That's the first question that they ask us, and then they ask us to energize it and then start recording the values of Zener current and Zener voltage that we see from 3 volts all the way up to 27 volts. Okay, so if I power this up in forward bias, we expect it to be a conduct as a regular diode and just see a subtle voltage drop across it. So we are at 3 volts now, or a little over 3, somewhere around there. We've got a Zener current of 0.006 amps. So we could call that 6 milliamps. Okay, and my Zener voltage over here is about 0.6. All right, we can go up to our 6 volt setting. Touchy. There's around 6. So now my current is 12 milliamps. Okay, and I've got still our 0.6 or 0.7 volts across the Zener. Increase it to 9. So we can see the current is going up. We got 18 milliamps, but that voltage is still being maintained at 0.6. Okay. So if we're going up by basically 6 milliamps every 3 volts, then at 12 volts we should see roughly 24 milliamps, which we have. And still our 0.6 over there. Okay, take it up to 15, we should be 30. Wow, big jump. Sorry. We're about 30 milliamps. Still our 0.6. Oh, actually we're up about 0.7 now. And then we are going to 18 volts. And we are 0.36 or 36 milliamps. And still our 0.7 over there now. And then we're going to go to, what do we want, 21? 21, and we're at 0.42 or 42 milliamps, sorry. And that's still the 0.7 over there. Okay, and then at 24 volts. We're at 0.048 or 48 milliamps, still 0.7. And then at 27, which is where the highest they want us to go, we're at 0.5, what did we get? 0.53. 0.55, 0.54, 55, somewhere around there, 55 milliamps. And we're at, so because we're up at 28 volts. So it's about 54. We're going up by basically 6 milliamps every time and still maintaining that 0.7. All right, so the next thing they ask us to do is shut that down. And then they ask us to reverse the polarity of the Zener. So in doing so, we are now taking our anode and cathode and connecting them up to the opposite polarities to what they were before. And in this case, we are now going to reverse bias it. And in reverse biasing it, we anticipate to see a block at that Zener. And then it's going to instantaneously start conducting and regulating at its Zener voltage. Now, we don't know what the Zener voltage is yet. We will certainly find out when it sticks at whatever it's going to go. And we're asking to go from 3 to 27 volts again. Okay, so I'm going to power up and I'm going to energize. And right off the bat, we're going to 3 volts. And we've got no current flowing. And we got 3 volts across that Zener. So 0 for current and 3 volts at the Zener. Okay, so it's acting like an open switch right now. Increase it up to 6 volts. Still no current flowing. And we got the 6 volts at that Zener. Okay, increase it to 9. Still no current and 9 volts there. Increase it to 12. 12 volts at the Zener, no current. 15. 50, oh, a little under, we're 13, and now we've got current flowing. Okay, so we're regulating at 13 volts here, 13.7. And we've got 4 milliamps of current flowing there. All right, so increase it to, what do they want, 18? We're at 14 volts over here now, and we've got 9 milliamps. So that 13.7 to 14 is roughly where that Zener voltage is. Okay, and then they want us to take it to 21, which we're there. We've got 15 milliamps of current flowing, and we're sitting at the 14. Volts at the Zener. Take it up to 24. Sorry, we're a little under there. Come on, touchy. Wow, this thing's touchy. Okay, 20 milliamps of current and still at 14 for the voltage at the Zener. And then 27. We're at a little over, we're at 27.8. It's really touchy. I'm doing my best here. Still at 14, now we got 30 milliamps of current flowing there. So you can see what's happened here is when the voltage was lower than the 14 volts in Zener, that was acting like an open switch. And then once that Zener voltage in reverse was broken through, it's now conducting and regulating at that. If we looked at the source voltage of 28, we've got 14 there. If we took another meter, we would see the other 14, the remaining voltage across that load. Okay, so I'm going to power that down. they ask us to build a graph up and then clean up the work area and then answer some questions, which we'll take up in the Learning Hub. But that was basically Lab 6-2, what is it, Zener characteristics, I guess? Is that what it was? Something like that. Zener diode current characteristics. Okay, see you on the next one.